Okay, so now we're at the next section, the last section of this particular section of chapter 5, where we're going to be talking about the comparison operator. In the last video, I kind of showed you how we compared 5 is equal to the string 5 and how that's true. I'm going to explain to you in a moment how the compiler knows that. So now let's get into the curriculum. 5.1.3.1 Comparison operators. The double operator is one of the 6 common comparison operators. Here we have comparison operators. Here's the operators. Equals or returns true if it has to be the double equal. The double equal returns true if the 2 operands are equal and false otherwise. As you can see right here, 7 double equal to 7. So instead of calling it double equal, I'm just going to say equal. 7 equal to 7 is true. Dog equal to dog string equal to dog string is true. 7 equal to 5 is false, and we can see that makes sense. A string dog equal to string cat, that's false. We can see that. But now this is where it may get a little confusing, and we call this the not equal. The exclamation point in programming is called a not, also a shebang. What the not represents, if you put a not in front of the equal sign, whether it's a double equal or triple equal, it reverses the comparison or the Boolean. So remember, in the truthy and the falsy, it's everything inside of the parenthesis of an if conditional is true, unless you state it to be false. And this is how you state it to be false. And this is dealing with more about state. So here we see 7 not equal to 5 is true. You can see how it can get confusing. So you're going to have to practice this in different ways to make sure you get your head around it. You may not get it right now, but keep practicing. It will make sense down the road. As you can see, dog string dog not equal to string cat is true. And you may be wondering again, why would we do that? And it's about state. You may want to set a variable to be true, but when you compare it, you want it to start off as false and change it to true in your statements. And like I said, we'll show you that when we get into writing functions. Then we have the greater than sign, which we understand 7 is greater than 5 is true. String B is greater than string A is true because B comes after A. And also too, this is something I want to explain to you. How the compiler knows all of this is because of binary numbers. It understands that a bit has 2 elements. It has a state and it has a value. And we're going to see in a moment the state and the value, how that comes together. And the compiler is able to distinguish what's what. So here it knows that the string B is bigger than the string A because, and notice this is a lowercase b and a lowercase a. It's bigger because of the binary value that's assigned to it. There's no magic here. And the more you can understand it, the more you'll be able to get your head around this. And so as we go down, we notice that if we want to do a greater than equal to, remember that the greater than, the equal, or the greater than, the less than, or the not has to come before the equal sign. If it comes after the equal sign, it will not be legal and you will get an error. And we'll talk a little bit more about this in the description. All right, as we go all the way down to the read more further, it says, although these operations are probably familiar, the JavaScript symbols are different from the mathematical symbols. So don't get confused with these symbols that you understand it in math. They're a little bit different here, and this is why we want to make sure you understand this. And a common error is to use a single equal sign instead of a double equal sign to show equality or to compare something to be equal. That's why I want you to practice not calling the single equal sign an equal sign. It's an assignment operator. And it says it here. Remember that the equal, single equal is an assignment operator and the double equal is a comparison operator. Also note that the equal sign before the less than or before the greater than are not recognized operators. So this is why I'm trying to get you to understand that this has to come before the equal sign. We use, this is called a fat arrow when we get into functions, and we'll explain to you later on what that is. So this means something in programming language. An equality test is symmetric, meaning that we can swap the places of the operands and the result is the same. For a variable a, if a is equal to 7 is true, then 7 equal to a is also true. However, an assignment statement is not symmetric. So this is why we got to make sure you understand this. An assignment statement is not symmetric. This is not an equal sign. This is an assignment operator. So A is assigned to 7. Remember, variables go on the left of the assignment operator, and expressions or number or any symbol goes on the right of the assignment operator. That's legal. But if you try to do a number on the left side, it's not going to work. Now, warning. If you explore the equality operator in more depth, you will find some surprises. For example, the following comparison returns true. 7 equal to string 7. And we saw that with 5. 0 is equal to false. 0 is equal to an empty string. Remember the truthy and the falsy. When you think about this, we know that 0 is assigned the state of false and 1 is assigned the state of true. False, 0 is equal to false because that's the value. Because we convert everything from human readable to machine readable, and it only reads byte code. And we know that falsely, an empty string is false. So that's why 0 is equal to an empty string. But here it says we will explore the nuances of double equal in the upcoming section, equality, and introduce 2 new operators, the 3 equal signs and the not with 2 equal signs. That will align more closely with our intuitive notion of equality. Now, here's something that I want you to understand. The reason why the compiler knows the difference. So let me go over here to, here we go. We had this Replit open, and we did a console.log. We compared 5 and let's do a double equal. So if I do a double equal here, it is going to be true, right? And how does it know that? It knows that because of the binary number. Now, I haven't taught you how to count in binary numbers, but the binary number for the number 5 is, or the value of 5 is 101. And so if it's 101, if I type in the actual number 5, then it gets converted. It gets compiled down to a binary code. But again, strictly double equal can distinguish between that because it's not comparing the types, and we'll explain that to you when we get to the triple equals. Now, it's something I want to bring out to you and help you understand. I want you to understand this table. This is called the ASCII binary chart table. And so here, the reason why it knows the difference is because, let me let's go in here, let me type in ASCII binary. Let me see if they give me what I want. All right, so let's see here. Let me go to this one. Same one. It didn't give me what I'm looking for. What I'm looking for, I want to type in, let me see. Let's look up binary. Binary chart. Decimal, binary, hexamal. Let me see if this is the one I want. Okay, this is kind of small. Let me bring it up. Okay, so here we go. So like I told you, 5 is 101. And remember, in binary, 8 bits is it's a byte. So 1, 2, 3, 4, 5, 6, 7, 8. So all zeros is 0. And then we get down here to number 5, 101. All we have to do is go up to 9. That's all we need. We don't need to go all the way up to infinity because we're able to reuse these each numbers because it goes by a place value. So now that we understand that when the compiler reads it, it sees that we're comparing number 5 and it gets converted down to a binary number, which is 101. And then it's comparing the soft equal, only can do it with the soft equal. It compares it with the string number 5 because that number 5, when that compiler sees it, it sees a number 5. It doesn't, like if I type in the word 5, F-I-V-E, it's going to see a totally different number. And the number for F, and there's a capital F and then there's a lowercase f. They have different values assigned to the binary numbers. So I'm hoping that makes sense to you and I didn't confuse you more. So one of the things that you want to do, you got to keep on practicing. This is why I say the more you practice, the more you improve. Like I said, don't get stuck here. Go to the end of the chapter and then come back and revisit these videos and play around with what I just introduced to you. So, okay, this is the end of this particular video. I want you to check your understanding and I'm going to see you in the next video. All right, take care.